Good afternoon, everyone. Thanks for joining us. As he said, this is going to be a tutorial in how you can use Pelican to connect your data to an existing data federation, much like the OSDF. So this is really intended to prime you to be able to contribute your data to the OSDF, though we won't be connecting specifically with the OSDF today. All right, so my name is Owen. I'm a research computing facilitator with CAGC and OSG and PATH, and I'm going to be guiding you through this tutorial today. All right, so the goal here is to enable those who are interested in contributing to something like the OSDF by introducing and guiding the software that we use for running the OSDF, which is Pelican. So you've already heard a couple of sessions about Pelican this week. We're going to start doing some of this stuff in practice. Okay, so at the end of this training, hopefully you'll be able to describe what the Pelican platform is able to do, identify potential use cases for Pelican platform, define some core concepts about Pelican and the data federation architecture, be able to access public data from a Pelican data federation. That part will hopefully be pretty easy. And then the meat of this is going to be able to walk through and deploy an origin on top of your data store. Okay, so there's two parts here. First is going to be some slides with an introduction. I'll go over OS Pool, OSDF, Pelican, how all these pieces fit together. And then we'll actually get into the hands-on portion of actually trying to run some of these services. All right, so introduction here. OS Pool and the OSDF. We already had a talk or two on the OSDF and what it does, but I'll give a brief overview here. So OS Pool is a high throughput computing system distributed across most of the United States. And this runs anywhere between 500,000 and 1 million jobs per day. So you can see some of the sites here on the map. Now, with this distributed computing comes the need for corresponding data distribution. And it needs to be able to work at a large scale and a large volume. So let's consider an example. You're submitting jobs here, and those jobs could run anywhere in the US. So if you got a lot of data that you're trying to compute on, you're gonna have to figure out how to move that data from where you're submitting or where you have it stored to where it's actually gonna run. So submitting many jobs, and in particular many jobs that use a large file repeatedly, can quickly flood the network with data transfers. So let's say you submitted somewhere here in the Midwest here, maybe from Madison or from Chicago, and it's gonna run out in San Diego. Well, when the first job runs, it transfers that large file, and the second job starts running, it transfers that file again, and you keep doing that repeatedly, and very quickly you can overwhelm the network traffic. Right? So let's say you have 10,000 jobs, you got a 10 gigabyte input file. That's not unreasonable for a container. And if you're transferring that file for every single job, we're already in the terabytes of network transfer here. So you can very quickly, overwhelm this pipeline between Chicago and San Diego for this set of 10,000 jobs. And as we saw earlier in the other presentations, 10,000 jobs is a drop in the bucket for a lot of the workflows that people are doing. Okay, so this is where the OSDF comes in. It's a system of data caches placed strategically across the country. And the idea is that we can stage these large, repeatedly used files much closer to where the actual compute is happening. So we're submitting, say, in Chicago. We transfer that file to San Diego, into one of the caches there. And each time that job starts running in San Diego, it's just going to repeatedly use that file from the cache. So what you can think about is instead of having to transfer, terabytes of data across the country, you now only have to transfer this file once or maybe a couple of times in practice. Now, in reality, you still need to transfer the data from the cache to the actual compute source, but oftentimes these caches are placed very close to or even in the same data center as the compute resources that we have available. So now instead of having to transfer 100 terabytes of data from Chicago to San Diego, you're transferring it from one block in San Diego to a different block in San Diego. All right, a little bit of stats. I'm just stealing this straight from Frank's presentation on Monday. So total OSDF usage in the continental US for June 2024, we're in the 25 petabytes read on the system. OS pool usage accounts for 10% of this, which is 2.5 petabytes. And this is what Frank was saying, that this transfer corresponds to 80% of a 100 gig network pipe. I don't fully understand what that statement means, but hopefully it makes sense to you folks. And then the cache system is saving a lot of these transfers. So, with the cache system, we're able to go to the cache, find the file we need for that job 97% of the time. So we don't have to transfer that file from Chicago to San Diego or to Florida, but 97% of the time. Okay, so I'm just going to link his talk here. You can go see more stats about OSDF. All right, so Pelican in the OSDF. Just like how the OSG uses HT Condor as the software that runs the OS pool, OSG is transitioning to use Pelican as the software that runs the OSDF. So for a long time, OSDF was a lot of custom sauce that the OSG put together to make work, and we're splitting that out into a standalone software and this gives us a few benefits, especially for the OSDF. So OSDF is the flagship instance of the Pelican software, and that allows for a more reliable and robust software stack, lots more room for new features and improvements, and it's more extensible to other contributors and data stores. So the goal here is a lot less special sauce, a lot more reproducible, easily contributing to the system. Okay, so what is Pelican? Pelican is a software platform for creating data federations, which serves to unite data contributors with data consumers, all under a single namespace. So the data contributors can connect their existing data stores to the data federation while maintaining their access policies. Data consumers can easily access objects from within the data federation without needing to know anything about the underlying infrastructure. All they need to know is what that object's name is in the store, and they're able to access it. So like the HT Condor software suite, Pelican platform is an open source software being developed here at the CHUC at University of Wisconsin-Madison. Here's the main website if you want to start poking around. Overall goals for Pelican developments, and this is my understanding of it, may not be what the actual dev team understanding of it is, but it's empowering infrastructure for target domains. In particular, climate data is a big driver of this platform. One of the main goals is to be able to support a wide range of storage backends to better support the users who are contributing the data, and to also support the users contributing the data, making the setup and use of Pelican servers easy and convenient, hopefully. Okay, so I'm going to start talking a bit more about the bits and pieces of Pelican and how it works to set us up for actually doing some of the hands-on stuff. So first is, what is a data federation? We've been throwing that around here. I stole this from the documentation website, but data federation is a collection of decentralized autonomous data repositories working together to make their data broadly available to other members of the federation under a minimally centralized structure. More information about this was in a previous session, so hopefully you remember that, and if not, you can look at the materials there. Okay, so that's what a data federation technically is, but how is the data actually used? How does it work? So the data is accessed through a unified namespace, regardless of where it comes from or what type of storage is used to serve it. Some or all of this contributed data can be restricted to specific authenticated members of the Federation. So just because you're contributing the data to the Federation doesn't mean that everyone in the Federation gets to see that data. Instead, you can control who actually has access to that. You can set it up so that everyone can see it. And in fact, you can, when you do that, you're saying anyone who knows the Federation exists can see it. I imagine there might be some ways of controlling that further. Okay, so when we talk about a data federation, we need a way to name it. We need to be able to say, this is the federation that I'm working with or that I'm working in. So we identify the federation by its federation URL. So for example, the OSDF uses osg-htc.org as the federation URL or the discovery URL for the federation. So this URL is used by any Pelican components to talk with the federation and find all the information it needs in order to interact with the federation. Okay, so components of the federation. We now know how to name a federation in terms of what is the identifying piece that we need to share. What are the actual components? So first one is, I'm going to do this in order of ease of use, in my opinion. Client is the piece of Pelican that you use to download the data or to upload, depending on how you're set up. So the client is used by the data consumers. And as you'll see as we go through and do the hands-on portion, the client is very lightweight, very easy to use, no root installation necessary. It's very easy to access data from the federation. The origin is the service that is run by the data contributors, and this is what integrates the data storage that you have with the data federation. So you're contributing the data, you'll need to run the origin to be able to tell the federation how your data can be accessed. The cache is typically run by the federation owners, and this is, as with the OSDF, is to stage data closer to the final destination, especially for repeated use. The director service is run by the federation owner and directs the access requests to the proper origin or cache. And then the registry is also run by the federation owner and records the identities of the federation's components. So a brief note here, I'm putting owner in quotations just because someone who quote unquote owns the federation doesn't actually own your data. They don't have control over your data. They don't necessarily are able to see your data. Instead, they are essentially in charge of this registry. And because the registry is the master list of the components of the federation, that means ultimately they get to decide who is actually a member of the federation and who can work with the other components to move data around the federation. But ultimately, whoever is running that origin has the control, has the power to decide who in the federation or not can access their data. Okay, so today's tutorial, we're going to focus on the client and origin. The other services are run by, like I said, the federation owner. So that's the OSDF and the OSDF management team. So for most people who are going to be interacting, they're either going to be using the client, or if you're a data provider, the origin. Okay, so a client is a user that is accessing data from the federation using the Pelican clients. So we have a CLI tool that you can download and run on your machine. And I think as was described one of the other sessions, there's a lot of other integrations that they're working on so that you can access your data from the federation. So in the access request, when you use the client, you need to provide the federation URL. So this is the identifier of the federation, the name of the desired object within the federation's namespace, and if the data access is restricted, some sort of authentication token to prove that you are permitted to access that data. The origin is a service that runs in front of the data store, so not necessarily on the same machine, but in front of. And this is run by the data contributor. So this is the interface between that data store and the federation. So when the origin is set up, it provides a namespace prefix, which denotes where in the federation's namespace its data that it serves can be found. The origin acts as an adapter between the storage backend and the federation. And in that process, that provides the owner fine-grained access to control the access to the data store. Okay. So the data access within the Pelican data federation comes from the Pelican URL, at least when you're using the command line interface. So it looks something like this. This first part here is just defining the metadata lookup protocol. It just says that you're using Pelican. The second bit is the federation's host name or root. So this is what identifies the federation that you're trying to use. And then there's the desired object name within that federation's namespace. And this object name is actually composed of two parts itself, where the first part is the namespace prefix. So this is what's defined by the origin and is registered with the federation. And then this is the object name. So this is the actual file that is in the data storage that the origin interfaces with. Okay, so I pulled this from the website. Actually, Brian Bachman gave a pretty good talk yesterday demonstrating all of these pieces. So I'm just going to briefly cover sort of what happens here. So as the client, you have this Pelican URL, which specifies the federation and the object's path or object name. And so the client talks to the director and asks, where can I find this object? The director looks in the registry list to see who or what origins or what caches serve that namespace prefix that the origin defines. It then returns to the client and says, go look at this machine, go look at this components. The client follows that redirect, asks for that object again, and in this example, in the graphic, it's going directly to the origin that was serving the namespace prefix you asked for, and then it looks for that particular file and it gets downloaded. So in this process, the director doesn't really care about the specific object name itself. It's only looking at the prefix, that namespace prefix. And furthermore, the director doesn't handle anything with the data transfer itself. It's just telling it where to look to find the storage that you're interested in. Okay. More information in Brian's talk, and I linked it here in this slide. Okay, so getting to how do you actually contribute to the data federation? Well, that involves running an origin, and how you set that up depends on what you're trying to do. So if you're trying to serve public data, so this is data that you're fine with anyone accessing, you don't need to restrict the access. Then you'll need to have a server that has a registered web domain and that is connected to your data store in some fashion. You'll have to configure this origin service to run on that server. You have to run the origin service. And then you'll need to register the origin service with the federation owner. That's just to essentially reserve that namespace that you want to use and make sure there aren't any name conflicts already in the origin or in the federation. And if you're trying to serve private data, or if you want to allow people to write data to your store, you're gonna have to do all of the above, plus you're gonna have to configure authentication services. So that's so that you're in some fashion able to generate tokens so that when the client comes and makes a request within the federation, it's able to authenticate with the origin to confirm that it has permission to access or write data on that origin. And more information about this was in Justin's talk from yesterday. So there's a lot of pieces to configuring an origin and getting it set up and things like that. And he described a lot of the components. And today we're going to actually try and use those pieces. Okay, that leads us to the hands-on tutorial. So hopefully this was a good primer for actually getting started and doing this stuff. We're going to move on into the hands-on portion here. So for the setup, so I'm going to be guiding you through how to run your own origin service to connect to public data to an OSDF-like federation. For this portion, if you registered in advance, we've set up a virtual machine that you can log into. We've already sorted out registering the machine, so the certificates and stuff are taken care of. And we've also given you access to Docker. So if you registered in advance, you'll be able to log into this machine. So to get started, if you did register in advance, please pull out your devices, your laptops, grab the materials from the GitHub page. So it's listed here. It's also in the session page on the schedule. You'll want to go to this because the commands used throughout this are all laid out on the GitHub, and it's just a lot easier to click the copy button and paste it into your terminal than it's going to be to type some of these commands out. So I highly encourage you do that. And in fact, I'm going to go ahead and open this up myself. Maybe. Okay. All right. So first step is going to be getting logged in. So for those of you who registered in advance, you should have gotten an email saying what your username is going to be. And basically, you're going to do an SSH using that username to pelican-train.chec.wisc.edu. All right, so once you logged in, you'll be directed to your particular virtual machine. And once you log in, you should repeat the process in a second window because we'll need 2 windows throughout this tutorial. All right, there's more detailed instructions in the GitHub README, and I'm also going to be demonstrating this as we go along. So hopefully in the time it takes me to do it, that'll be pretty close to how long it takes you to do it as well. All right, so I'm going to take a look at that GitHub page. The README here has all the instructions that we're going to be following for this tutorial. And we'll want to start out with the setup. So logging in, we'll want to use SSH to connect to one of these servers here. And I'm going to be doing that in my terminal window. And I'm going to try and see if I can split this. All right. All right, so I'm going to copy that SSH command and paste it in, but then I'm going to go through and change this co-manage username to be my username. And for you, you should use your username that you got in that email. If you try to use mine, you're going to run into some authentication problems. All right. So I'm going to do an SSH. All right, you'll be asked to confirm the authenticity of the host. Yes, and good security-wise, you probably shouldn't just randomly accept these things, but hopefully it looks like the same IP address that I have up here on my screen, and we should be good to go. Assuming they didn't spook the IP. All right, so you'll see a prompt to do a CI logon. So I have a link that's been generated. This is generated, it's a custom link for my login. This is using CI logon, which was subject of a lightning talk yesterday. And I'm going to copy that link and put it into an incognito browser so you can see what this should look like. All right, so this link will redirect you to a CI logon page. Make sure that you select the same identity provider that you did when you registered. If you do a different provider, then it won't authenticate correctly and it won't work for you. All right. This is my Madison accounts. So I'm going to select University of Wisconsin-Madison. It directs me to my institution login. Yours may look different, especially if you're not at UW-Madison. And I'm going to log in. My institution has two-factor authentication, so I'm going to do my two-factor authentication. And once I do that, it's going to direct me to a page like this. So if you've successfully logged in with your institution, what you should see is something like this, that it says you've successfully approved this login or this user code. Return to your device for further instructions. So if I go back to my terminal, at the bottom it says hit enter when the website tells you to return to your device. I hit the enter key. There we go. Okay. So you'll see a welcome message from CHTC. And what you should see in the prompt here is trainee at Pelican train some number. So you'll want to make a note of this for later. Of course, it's available here, but hopefully you are now logged in. Okay, so I'm going to repeat this process in another window because I want to, oh, wrong one. We want to have a second window open in order to do the different sets of commands later. So I'm going to repeat this process. I have control master set up, so it remembered my login. You may have to repeat some of the authentication stuff depending on your SSH configuration. Okay, so I have two windows open, and I'll work with them later. Let's try and get these sizes to match. One more. Okay. All right, I'm going to switch back to my slides here. As I said, these instructions are all in the GitHub README as well. So if you're having issues or you're going a little slow, it shouldn't be a problem. All right, I don't want that window. I want my slides. Okay, so hopefully everyone has been able to log in. Yeah, so if you haven't been able to log in, if you're in person, please raise your hand so someone can come help you. If you're online, put a message in the chats and someone online will try and assist you. Okay. All right, so to set this up, we're going to clone the GitHub materials. So this is just the same GitHub repository that we were looking at. Make sure you're in your home directory because commands later on are assuming you're in your home directory, and then run the git clone command. So we have some prepared files that are going to make it easier for the rest of the process here, so you don't have to try and type a bunch of stuff by hand. All right. So I have my terminal here. And if you have the GitHub repository open on your browser, then what's really nice is you can come in, find the command under clone the materials, click the copy button, copied, come back to your terminal, paste it in, and hit enter. Okay. You only have to do this in one of the terminals. You don't have to do it in both. That would just repeat things. What's that? You shouldn't have to. I set this branch to be the default. So you should just be able to clone the main sites. I just included the branch name for future reference once I change that default. So if I do an ls, I'll now see that there is a folder training-origin. And if I look into, or if I move into that folder and take a look around, I'll see the README file. I'll also see two directories, clients, Pelican-clients and Pelican-origin. So in this tutorial, the first part is going to be playing around with the client to download some data. Second part is going to be setting up our origin. So that's why these two different folders. And once we set up our origin, we're going to move back to using the client to try and download data via the origin. So it's organized already, so you don't have to worry about making those directories. And in the origin directory is some additional files. Okay. So throughout this, I'm going to have explanation slides and then the actual slides for doing the commands. And of course, all the commands are in the GitHub README as well. So the Pelican clients can be used to get and put objects from an existing data federation. And it's available as a standalone binary from the Pelican platform's website. So there's no installation required to use the clients. You just have to download and unpack that file, and it's ready to go. All right. So that's what we're going to do here. So we're going to quote unquote install the Pelican clients. To do this, we're going to go into that Pelican clients directory, copy that file from the web, or download that file from the website, and extract the binary file from the tarball. All right. So I'm going to go ahead and start doing that now. So in the README, we're in the using Pelican client to transfer data and download and extract the Pelican client. So I'm going to make sure I'm in the right directory. So I'm just moving into the Pelican clients. If you copy and paste that command, it shouldn't matter where you are in the system. You'll be able to move to the right directory. And if you do an ls, there isn't anything in here yet. It's just set up for an organization here. Switch back to the GitHub, copy the commands for the wget command here to grab the tarball. Now, you should do this specific command because we're working with version 7.9.2. I haven't tested it with newer versions, so if there's been a change and hopefully it doesn't break anything, it may. All right, so I run the wget commands, and we should see a tarball has been downloaded. We just need to now extract that tarball. So I'll copy the commands, paste it in, and hit enter. So we'll see a new directory, Pelican-7.9.2. And if we look in that directory, we will see the Pelican binary. Okay. And that's it. That's all we need to do to get the Pelican binary. In practice, you might want to add that to your path so that you see it elsewhere, but we won't do that today. All right. So we now have the Pelican binary inside of this directory, and that's the same directory we're going to use for downloading our test objects. Okay, so a reminder about how the data transfer works with Pelican. So you need to provide a Pelican URL, something that has these pieces, the Pelican protocol, the federation's host name or root URL, and then the desired object name. And then, as Brian was mentioning yesterday, these commands are just like any other HTTP get put request. So in this case, the command is going to be Pelican object. So it uses the noun verb syntax. Pelican object gets this URL, and then what you want the object to be named in the local directory. Okay, so the official test file here has a very long URL name. This is why I highly recommend you have that GitHub page open so you can copy your commands instead of trying to type this. But we're going to move into the same directory as the Pelican binary and run that object get command to fetch that URL and create this downloaded test.txt, and then look in it and we should see hello world. All right, so we're now in the use the Pelican client section. So I'm going to make sure I'm in the right directory. And let's see if I can actually, it's not going to let me do this. There we go. Sorry, I'm just trying to rearrange my screens. All right, so scrolling back to where I was, use the Pelican client. So we're going to CD into the right directory. Oh, I just did that. Now we're going to get this test object from the OSDF Federation. So Pelican object gets the Pelican URL and what I want to call the file. All right, you may see a very brief progress bar when this happens. But then once that's done, if you hit ls, you should see a new file, downloaded test.txt. And if we take a look at its contents, hello world. All right. All of these steps so far are actually in the Pelican documentation itself. So anyone should be able to do this, hopefully. You don't have to be in the VM to make this happen. If you wanted, you could download the client for your computer. This should all still work. All right. Okay, so that was using the client to download a file. Because it's public data, that's all we needed to do. We didn't have to provide any authentication tokens to access restricted data, which makes it a lot easier. Now we're going to get into the meat, which is configuring your origin. All right, so to serve your own origin, Pelican team recommends that you use a Docker container. But then in the configuration, you provide the details and specifics about your server and about your data that you're trying to contribute to the system. So to do this, as I mentioned earlier, you're going to need a server that has a registered web domain, so it has its web host certificates. You'll need a set of issuer credentials, and we're going to generate that in a second, and I'll talk more about that. You'll need to have a couple of open ports on this server so that it's able to talk to the internet, and a Pelican-specific configuration file with all of this information, as well as the information about the namespace and the data that you're trying to serve. By default, Pelican's going to look in /etc/Pelican for its configuration files and anything else that it thinks it needs. It'll also generate files there as well when you run the service. We're going to be mounting the files we need into the Docker container. So the VMs that we're using for the hands-on portion here, we've already handled the registration of the web domain. That's taken care of. We've taken care of the ports issue. And so what we're going to do is the issuer credentials, and I'll talk more about that in a second, and the configuration file. Okay. So first, what we're going to do is take a look at the origin directory itself that we have for the materials. So if I go into the origins directory or the Pelican origin directory, you'll see a couple of files. We have config, we have data, and then we have a script for actually starting the origin service. Basically, that has a Docker command in it, as well as some checks to make sure things are set up right. If we look in the config directory, we have a pelican.yaml. We'll talk about that in a second. And if we look in the data directory, we have a test.txt file. So the idea is the configuration that the origin service needs in order to run is going to be in that pelican.yaml file. And then the data that we're serving is in this data folder. All right, if you want, you can modify the contents of that text file. If you want to have a different message to prove to yourself things are working, up to you. I'm not going to mess with it. We have a directory structure that looks something like this. As I mentioned, config is going to be the configuration files for running the origin service, and then the data is the data store. As I mentioned earlier, this data store doesn't actually have to be on this machine. You can configure Pelican to have a different data location, but for the ease of this tutorial, where everything's in the same place. So this pelican.yaml with the Docker command is going to be mounted into the proper etc Pelican location, and the data folder in turn is going to be mounted into /data inside of the Docker container. Okay. So next, we're going to talk about that issuer credential I mentioned. So Pelican follows the OpenID Connect protocol for authentication. So your origin needs an issuer key pair in order to authenticate itself with the federation and to use for authenticating data access. So when you register with the federation, you're going to use this key pair both to say, here's my server, I want to be a part of the federation. You'll also be registering the namespace as well. So those are two separate registrations, but you'll need to have both. This all happens automatically when you start up the origin. When your origin connects to the federation for the first time, it's going to associate the domain with this key pair. So we recommend, we recommend pre-generating this key so that when you're running the origin service and let's say it crashes and you need to restart it, you can just provide that same key and it'll still connect and be registered and you don't have to repeat that process. If you don't have this key, then Pelican will automatically generate a new one for you, which is convenience if you're doing this for the first time. If you are doing this multiple times with the same namespace, that becomes a headache. Okay, you can use Pelican to generate this key pair. So there isn't anything too fancy that you need to do to make this work. I don't really know much about OIDC or authentication and tokens, so I'm sure there's a way of integrating other systems in with this setup. So for this training, what we're going to do is move into that configuration directory for the Pelican origin. We're going to use the Pelican binary to generate this key pair. And when we're done, we should see a couple of these JWK files in the config directory. Okay, so we're going to do that here. So we're now in the generate the issuer JWK in the GitHub README. Want to make sure that you're in the config directory. So if you've been moving around, you can copy that command to get in the right place. We're then going to use the Pelican binary to generate the pair of keys or the pair of files. This assumes that you have been following all of the commands correctly so far. If you put your Pelican binary in a different directory, this may not work as expected. So I'm going to paste this in because I'm providing the path to that binary that we downloaded in an earlier step here. And then we're going to do the generate keygen. Maybe. There we go. Okay, so you'll see something like this, successfully generated keys. It lists the private key and it lists the public key. All right. So this part should be good to go here. And now we're going to look into the configuration file. All right, is everyone on pace with me? Am I going too fast, too slow?
Personal VM. Oh, thanks. I'm just using my personal VM.
Okay.
And it's having an issue finding the user that it's trying to run the keygen as. Is there something I can change in a config somewhere to get that to work, or am I just?
I don't know. I haven't run into that issue before. So I guess maybe one of the Pelican. I think Hao Ming's behind you. He can help you with this. Yeah, if you're trying to follow along on your own VM, you may have mixed results just because I'm assuming a controlled environment here and all the pieces are in the right place. So good luck. We'll try to help as we can. Yeah. All right. Okay, so if you are using one of the VMs we provided you, hopefully this went smoothly. And we're good to go to the next step here. Okay, so now we're going to talk about the configuration file. All right, so, well, after we generate that pair of keys, you should have a directory structure that looks like this. So in the config directory are now these new .jwk and, well, technically JWKs. in the Docker command that we'll be running later, this is going to be mounted into etc Pelican because in the configuration file, that's where I'm going to tell it to look, which leads us into the configuration file. So by default, Pelican is looking in etc/pelican/pelican.yaml for its specific configuration for execution. At least the Pelican services will look in this location. I think the clients might behave a little bit differently by default. So we've already prepared this YAML file for you in the GitHub materials. It's in the config directory of the origin directory. This file is going to be mounted into the proper location with Docker, and let's take a look at the contents. All right, so you can open it up on your own browser if you want. I also have it duplicated in the slides here. So some parts that we have, the first section is detailing the server. So we're setting up the server that's going to be running the origin. And we got a couple sections within that. We have the issuer key and JWKS files. So that's what we just generated. We're telling Pelican where to find those keys on this server that we're going to be running, or this service that we're running. There are some TLS credentials that we're providing as well. In the case of the virtual machines that we provided, we generated those already, and those are going to be mounted into etc directly. And then there's the host name. So this is the web domain for this server. And as you can see, we have vmname.chc.wis.edu. Question? All right. The question is, if you're setting this up yourself for the TLS certificates, do you need a full chain or just, I guess, a partial chain? I don't know. So I'm here and you'll need a full chain for it? Okay. Yeah, this is one of the areas where I'm not a sysadmin. I don't do any networking. I have no idea what a TLS credential is in the first place. So I asked the operations team to just, hey, can you make this happen? Great. And that's where we are now. Okay, so this is a section configuring the server. Next is a section that configures the federation. And this is just specifying what is the federation that we are participating in, that we're contributing to. And as I mentioned earlier, all you need is that federation URL, or technically it's the federation's discovery URL. So just this root address, you provide that, and the federation is set up that Pelican is able to construct the links and the things that it needs just based off of this root URL, and then finds all of the metadata it needs to operate and to be able to talk to the other components of the federation. So that's all you need to do, is provide this for the federation. Now, this specific one is for the OSDF test instance. So this OSDF-itb.osghc.org. The actual OSDF one is without OSDF-itb, as I showed in a previous slide. Okay, the next section here in the configuration file is to actually configure the origin service itself. So this is the service that we want to run using Pelican. And there's a couple of options here. You'll see there's an enable direct reads equals true. This is telling Pelican that it's okay for the clients to ask directly the origin for the file. It doesn't have to go through the cache system to download an object. Okay, that's saying that anything that this service serves is going to have this enabled. The next part here, exports. So this is listing all the prefixes that we want to serve within the federation. So for the federation prefix, we have /HTC24-VM name. You're gonna have to edit this file to change that to your actual VM name. But then we have the storage prefix. So this is saying where is the data on the current server or connected server, I guess. And we're listing the capabilities for this specific namespace prefix. So we're saying public reads, anyone can see this data from this namespace. Listings, I think, enables the ability to list the objects that are in that namespace. And then direct reads is just a kind of a repeat from above. So remember, with how we're setting this up, we're going to have our data in /data inside of the Docker container. And within this federation that we're connecting to, those objects are going to be available by looking in /HTC24 the VM name. All right, so we do have to edit this file. Hopefully you're comfortable with command line editors. So you'll want to open up this pelican.yaml file, and there are two instances of where we have this VM-name in brackets. You'll need to replace that with your VM's actual host name. So that's what we're going to do here. These instructions, again, are in the GitHub README. So we're in the edit, explore the Pelican configuration file. All right. Okay, so we need to edit the file. It shows the two spots in the namespace or the federation prefix and in the host name here. And you can also look elsewhere. If you're comfortable with sed, you can use sed as well. I'm going to do this manually with VI. So I'm in the config directory with the pelican.yaml file. I'm going to open that up with VI. All right, so first one, line 10, the host name. We'll want to change bracket VM name to my actual host name. If you've forgotten, maybe look in your other terminal. So mine's Pelican Train 2002. Yours might be Pelican Train 2005 or something else. Make sure you're using your specific host name. Otherwise, I think the TLS certificates might not work. All right, so I got Pelican Train 2002 for the host name. And if I keep scrolling through the file, later on is the federation prefix. This is line 22. I'm going to do the same thing where I delete that bracketed VM name and put in Pelican Train 2000 whatever. Okay. So that's the only two spots in the configuration file that we need to change. Everything else is ready to go. All right, so I'm going to save that file. All right. And now we get into the fun part. We're going to start actually running this. Okay, so don't run this command. This is the big scary Docker command that I didn't want you to type manually. I am going to break down what we're doing here to try and explain what's happening. So this command is inside of the startorigin.sh file that you may have noticed earlier. There's also some checks to make sure you're in the right location, because if you try to do this in the wrong directory, things break nastily. Okay, so we have a Docker command. We're going to make sure that the ports are open that we're going to be using. I think by default, we do 8443 is the web interface, and then 8444 is going to be for listening for data transfers. The next part of this Docker command, I'm mounting in the issuer keys that we generated in that earlier step. So they were in that config directory. I want to put them into /etc/pelican. Similarly, I'm going to be mounting in the web host certificates for my domain. This is what the admin did for me, so I didn't have to worry about it. But in each of the VMs is going to have their own unique hostcert.pem and hostkey.pem. We're going to mount those into just the same location inside of the Docker container. We are mounting in the Pelican configuration. So this pelican.yaml that we were editing, we're going to make sure that's in the right location inside of the Docker container. And then we're putting our data storage into /data. This is the actual container that we're going to be using. So Pelican provides these containers. Anyone can use them, this is my understanding. And then we're going to be using version 7.9.2 because that's what I actually tested everything with. And then this is the actual command that's being passed into the container's run scripts that runs by default when you use this container. In this case, we're saying serve and then on this port. So we're serving the Pelican origin and we're opening up this specific port to accept the data transfers. Okay, so big scary Docker commands, but like I said, this is inside of a script, so you don't have to type it out or even copy it in the first place. So next, we're actually going to launch the Pelican origin. So you want to make sure you are in the correct directory. So you need to be in the Pelican-origin directory before you try to run this script. I put some functions in there to check that it's in the right directory. So hopefully if you're in the wrong one, that errors out appropriately. All right, and then if you're in that directory, you should be able to just run this script, and that's going to do the Docker commands and launch the origin service. So when we do this, don't cancel it out unless it's erroring very badly. And we're going to just let it sit. We're going to let it run in this one window. And then when we actually want to work with the data transfers, we're going to use the second terminal window. Okay, so we're in the start the origin service section of the README. Like I said, you really want to make sure you're in the right directory for this. All right, so I'm in the Pelican-origin directory. If I do an ls, I see my config directory, I see my data directory, and I see the run script or the start script here. All right, and more details in the GitHub. So then all we have to do is run this script, and it should just work. Okay, so I'm going to scroll up a bit and show what some of the output was. See here, it looks like I scrolled too far. All right, initially run environment for Pelican. You may see some stuff about pulling the container, so some Docker output about pulling the container image itself. But then once that is done, you should see this initializing run environments. You'll see some stuff here about OAuth. You can just glance over all that stuff. All right, you'll see something about starting Pelican, running Pelican with arguments. There's a bug with the versioning number, so this 7.9.3 is technically correct. We're working on that. You'll see some version information about when this container image was built. And then once all that's run through, hopefully what you see is this Pelican admin interface is not initialized. To initialize, log in here with the following code. All right, so that's what's coming up next. So we're just going to leave this window alone here. We're not going to cancel this out. I'm going to talk about this step. So this is the admin interface, web interface, that will allow you to interact with your origin, monitor it, control the configuration without having to use the command line. So this is the convenient part of the service that of the platform that we're trying to do. So what you'll need to do is copy that link, put it in your web browser, enter this one-time code that was printed out at the bottom. It's going to be different than whatever you see on my screen. And you'll be asked to create a password. That's optional for this tutorial. Of course, for production, you absolutely should create an admin password for interfacing. And then you should be logged in to the web interface. So that's what I'm going to do now. I'm going to go ahead and open this up. Let's see here. I'm trying to decide what window to put this in. Whatever, we'll just go here. All right, so we'll see something that looks like that. I'm just going to copy that code. So when you put in that link, you'll see a window that looks like this. Put in that activation code that you had. If you're pasting it in, it'll automatically hit activate. You'll be asked to create a password. Like I said, for this tutorial, it's optional. For production, you absolutely want to. And here we go. Okay. You may have seen this earlier. I think it was in Justin's talk. He was pointing out this interface, or maybe Jason's. I don't recall. You should see something that looks very much like this. So in the top left corner, we have a bunch of statuses, and hopefully it's all green boxes if we set everything up correctly. In the right, you'll see some stuff about the data that's being exported. So there's a section on the origin, there's a section on the namespaces. You'll see these complete registration bits. For the OSDF, by default, you have to complete this registration step in order to use the OSDF system. For today, for this tutorial, we've turned it off for our test instance. so that you don't technically have to go through and register this. In practice, what this means is the federation owner, and more accurately, whoever's controlling that registry service, has to go into the interface and click approve in order to accept the components into the federation. For today, because there's like 20 plus participants, we are going to make William go through and click all those boxes. So we've turned off that setting for now. You'll see a section in the namespaces. There is what you are serving. So if you edited the configuration properly, you should see HTC24-Pelican train 2000 something. And then that storage prefix is that same thing that we saw earlier, the /data. And you can see the capabilities listed here as well. So this is how this data is able to be accessed via the origin. We have a section on the transfer rate. By these default graph settings, you will not be able to see our transfers that we're going to be doing in a second. But if you really wanted, you could play around with that and you can see the byte transfers. And then Federation Overview is just a link to the Federation's interface. In the top left corner is a little wrench. This is the configuration menu for this service. So I'm going to click on that. You'll see a bunch of configuration options. So some of these are filled in because we had them in our configuration file. Some of these are filled in because they're filled in by default for running this service. You could scroll through the little question marks here. We'll link you to the corresponding entry in our docs. So let's see here, what's a good one to pick on? Enable reads, there we go. So I click on that question mark, it'll take you to the little card in the configuration docs on the Pelican website, and you can read more about that option there. There's also a quick jump in the side here to navigate through all that stuff. If you want to go back to the main page, you can just click on the Pelican in the corner or O for origin. And then we're back. Okay. Hopefully you all have green boxes. Hopefully this is all set up right. If you're in person and you don't see something like this, please raise your hand so that someone can come help you. If you're online, feel free to post something in the chat. Okay, so that's the web interface. Now we're going to talk about transferring the data using this origin service that you're running. So once it's connected to the federation, you can serve data to the federation. So this is a step-by-step. This isn't commands to run. The client that wants an object from your namespace is going to use that Pelican URL, and the clients will talk to the director service. The director service looks up who serves that namespace. So in this case, HTC24-Pelican train 2000 whatever. And it's going to look up that server's details and send a redirect back to the client. The client is going to ask the origin in this case, or one of the caches, it's going to request that object, and the origin gets to decide whether or not it allows that request. Because we have public reads turned on, it doesn't care. Anyone can read the objects in our data. Okay. So what we need to download data from this origin, again, are these pieces of this Pelican URL. We need that Pelican part in the front. We have our federation's host name. So this is the test instance host name for the OSDF. And then we'll need the desired object name. And remember, that's the combination of your prefix that you configured for your origin and the object name. So this is where inside of that data store, what is that object's name? So in the following slides, I'm gonna shorten things up. I'm gonna have Pelican URL, and it's gonna be this whole thing here. All right, and also these commands are in the GitHub page. So to start with, we're gonna use a special option where we tell the clients we want to download the object directly from the origin. So we're going to move into the client's directory where we have that Pelican binary. So to clarify, we're doing this in the second window. So the terminal that is running your Docker command that is running that origin, we're just going to leave that alone. We're not going to touch it. In your second terminal that you hopefully logged into, we're going to move into the client directory, and we're going to try and fetch the test object from your storage. And then take a look. If you change your test .text, you should see whatever you changed. Okay. So in the README, we're past the initialize the web interface. Let's see here, transferring data via your origin. So like I said, first, we're going to download directly from your origin. So like I said, leave the Docker window alone. We're not going to touch that. We're going to open our other terminal. We're going to move into, so this assumes that you have logged in that second terminal. Going to move into the client directory. We should see the Pelican binary and then your downloaded test from earlier. We're going to run this object get commands using the binary, but with a special option, $direct read. Okay, so I'm going to copy that from my GitHub page. Make sure that you actually edit the prefix name here to match your origin. If you just copy and paste this command, and I'll demonstrate this so you can see what the error is. All right, you'll see something, a couple of error messages, failure to get getting this address, failed to get namespace information. No namespace found for path. Well, it's because you have a couple of number signs in there, and that needs to be changed to whatever your actual origin is, or to your actual namespace. All right, so I'm going to paste in my command again. I'm on 2002, so I'm going to change that to 2002. Make sure you change it to whatever your specific number is. At the end of the Pelican URL is the $direct read. So this is a special query option that we're passing to tell it we want to grab this directly from the origin. We don't care about caches. We want to go directly from the origin. And I'm calling this direct read test.text. I run that command. No errors this time because I ran it correctly. And then we have direct read test.text. If I take a look at the contents, hello world from HTC24, unless you edit it, in which case it should be whatever you edit it to. All right. I'm sorry, I didn't hear. Can you run this command with a debug option on? Dash what? Dash D? Okay. Well, I think I don't know where to put it. Anywhere? Well. I think what happened here is because the file already exists, it didn't want to. I'm not sure. Okay, I haven't run this command before. I have no idea what any of this means. So. Oh, okay. Gotcha. Yeah. Yeah, okay. So for those of you following along online, we added this -D option into the commands. I'm being told that this is just logging what are the steps that the client is doing to download this object. And so if you want to do that yourself, you can take a look at all of the things that are happening. So I think it's looking at the Federation's discovery URL, getting the necessary information for the director service. It's querying the object from the director or the namespace from the director, doing some more stuff. Apparently tried to a cache anyways. That's a little confusing. And then downloaded or didn't download. I'm not really sure. Anyways, we have that file. Doing this live, so not sure how helpful this is. Okay, so that was the direct read. This should be going directly to the origin to grab the object. Okay, check the contents. Okay, now we're going to use the cache system. Okay, so this step is pretty much the same thing, except now we're not going to have the direct read option turned on. So by default, Pelican is you're going to use the cache system for transferring your object. So this was described yesterday. Your client's going to talk to the director. Director is going to return a redirect to a cache. If the cache doesn't have that object, it's going to talk to the director, get a redirect to the origin, and then pull the object, and then the client will pull the object from the cache. This is set up by default, but there's a little bit of a delay between the origin coming online and the cache is recognizing that the origin exists. So that's why we're doing this in this order where we query the origin first. So there was time for the cache system to come online. So when we do this defaults, it should work. Okay, so it's basically going to be the same command, except now I'm going to remove that direct read option from the end of my URL, and I'm going to change the name of the object to be cache read test.txt. Okay, so again, these commands are in the GitHub. I'm going to go ahead and paste that in. Remember to change your VM name to be whatever it actually is. And cache read.txt is just the same content. So I downloaded the same object, just with a different name. If you wanted, you could probably do that -D option to see what's happening behind the scenes. And hopefully that says something about talking to a cache. But I'm not familiar with this output, so I won't try to go into more detail. Okay. So this cache system that we're using here is intended to stage the repeatedly used data closer to the actual destination. By default, director is going to redirects the request to the cache. It's cached within the object. It pulls or it asks for the origin and gets it from there. And then once the cache has it, the client will download it. And then the next time that the client requests the object, the cache is just going to provide that without going back and talking to the origin. But the cache has a copy of the access rule. So if you have restricted data, that cache isn't just going to give up that data no matter what. It's going to follow those same rules that the origin has for accessing data. Now, the next part that we're going to explore is that changes to the object at the origin are not propagated to the caches. So if your object is in a cache and that's where you're pulling it from, but you change it on the origin, that isn't getting passed forward. And so there can be mismatches from what you expect versus what's actually happening. And that's what this next part here is talking about. I have no idea how I'm doing on time. Am I running long? Do I need to wrap up? Oh, okay, 2 minutes left. Great. Okay, so basically, the instructions are in the GitHub. You can go ahead and follow along there. I'm going to narrate as I go, just because I am short on time here. But I'm going to move up to where my data is located. So that was in the Pelican origin / data. I'm going to rename my objects. All right, so I'm changing the object name from test.txt to renamed test.txt. All right. So I no longer have test.txt as an object on my origin. So when I move back into the client directory with the binary, all right, I'm going to remove my previous reads that I did. Okay, and if I try to run my commands again, so first I'm going to do a direct read. Let's see here. That looks right to me. If I try to do a direct read from the origin, I'm going to get an error. And it's going to say, let's see here, there are currently no origins hosting the object. So it found an origin that had the namespace 2002, or this HTC24 Pelican train 2002. But there wasn't an object there called test.txt, right? Because I renamed that object on that origin to rename test.txt. But if I do this command again and I'm going to lop off the direct read option, change the name back to cache read test.txt. So I'm still trying to grab this test.txt object that I had been serving earlier and that I pulled through a cache earlier. And I'm going to be using the default cache system. Now it works, right? The object existed on the cache, but not on the origin. So when I use the cache system, which is the default, I was able to pull this object, even though I renamed it. All right, and then just to quick look at the contents, yes, hello world from HTC24. All right. Some other things you could do as I'm over time here. So you could work with a neighbor, try to download data from each other's origins. Think about what information do you need to communicate to your neighbor in order to facilitate that download. You could try stopping the origin, seeing what happens if you try to pull directly or not. You could try changing the contents of the object at the origin and compare what it looks like when you pull from the origin versus when you pull from the cache. You could also try to restart the origin, mess around with the config, see how things work that way. Additional considerations here, authenticating data transfers. The origin needs to be configured with an authentication method to let this happen. And the idea is somehow the token is going to be generated at the origin. That's communicated with the user or with the client. And then the client is going to pass that token along with its request. And as long as you do that, then you can access restricted data or the appropriate restricted data. And authentication is turned on for write. I'm not even sure you can turn it off. So if you want to write data to the origin, you have to use this approach. More about this at an upcoming tutorial. Additional considerations joining the OSDF, there's going to be some different configurations that you're going to use instead of what we have here. And really the short answer is contact us. We'll want to talk about what is the data that you're trying to serve, where is it, how do you want it configured, things like that. And it's really, it's a conversation. So reach out to us about that. More information on Pelican. Here's the links for the website and the documentation page. Information about the OSDF is on this website. Today's tutorial, all these materials are links to the session page. PERC tutorial, July 22nd through whatever is the PERC 24 out in Rhode Island. We're going to be there with another tutorial. It's going to be pretty much similar to this. The first half, at least, is going to be pretty much the same thing, unless we make some major changes. I don't know. Second half is going to cover more of that authentication and token stuff that I was mentioning. For OSDF support, feel free to send an email to the main support email for the OSG. And for Pelican support, there's a different email address there if you have specific Pelican questions. All right, I'm over time. We'll end it there. Hopefully this is a useful exercise, and I'll take any questions.